Black holes. There seems to be a lot of black hole talk in recent months and years, and while these mysterious phenomena of the universe have been studied for the better part of a century, there are still several unanswered questions. In this video, we will explore what happens when two black holes collide. Most big galaxies in the universe contain supermassive black holes, with masses ranging from millions to billions of suns. We don't know how these massive, immensely dense entities formed or what causes some of them to begin devouring surrounding matter at incredibly fast speeds. Black holes are among the most fascinating things in the universe. They are regions of space where the gravitational pull is so powerful that nothing, not even light, can escape. Black holes come in various sizes and can form in different ways, but the collision of two black holes is one of the most exciting and possibly devastating possibilities. A normal exploding star, known as a supernova, can light up a whole galaxy. Consider what would happen if 100 million of them burst simultaneously. That is how a black hole merger looks when two black holes collide. It is a cosmic event of epic proportions. When a big star collapses, creating a singularity where the laws of physics as we know them are broken, extremely dense objects called black holes are formed. An event horizon surrounds these singularities, creating a boundary beyond which nothing can escape the gravitational attraction of the black hole. At the centers of galaxies, supermassive black holes, millions to billions of times more massive than the Sun, are prevalent. When galaxies collide, their center black holes should fuse as well, causing intense collisions that result in spacetime distortions known as gravitational waves, a concept proposed by Albert Einstein in 1916. Astronomers predict that the combined strength of two supermassive black holes would be briefly greater than the combined luminosity of all stars in all galaxies in the entire observable universe. The acceleration of large objects causes gravitational waves, which are ripples in the fabric of spacetime. Sensitive devices like the Laser Interferometer Gravitational Wave Observatory and the Virgo detector can pick up gravitational waves emitted when two black holes orbit each other in a binary system. Using LOGOS, astronomers identify gravitational waves from the merging of two tiny black holes located 1.3 billion light-years apart. The surrounding spacetime fabric may be significantly affected by the collision of two black holes, similar to how a stone placed into a pond causes ripples on the surface. The merger has the potential to produce gravitational waves that ripple through spacetime, deforming its structure. Gravitational waves are created when two black holes collide and unleash a tremendous amount of energy. The collision releases energy comparable to several times the mass of the Sun, potentially creating a larger black hole from the collision of two smaller ones. As the black holes spiral towards each other, they lose energy in the form of gravitational waves, slowing down and finally combining into a single, larger black hole. Coalescence is the process through which two black holes combine. The collision can also cause the ejection of material from the system, in addition to the release of energy and the creation of a larger black hole. A disk of gas and matter may form around the merging black holes, which may then be expelled into space. Stars, planets, and other celestial bodies drawn into the gravitational pull of the black holes can be found in this material. Directly observing the uncommon and strong event of the collision of two black holes is challenging. To put it into perspective, the energy produced during the collision is greater than the sum of the energy produced by all the stars in the observable universe. The merger of two black holes is one of the universe's most intense, violent, and energetic phenomena. Black holes revolve at incredible speeds, 1/3 to half the speed of light in some situations, and are frequently more than 100 million times the mass of our Sun. There is an opposing notion that the two black holes may negatively interact and recoil from one another due to their rapid rotation. More Lego-like sensors are being built around the world to help locate the locations of other black hole collisions. This new preoccupation with black hole research will provide us with even more fascinating insights into the nature of the cosmos and the reality behind our universe's most mysterious and terrifying occurrences. In conclusion, the encounter between two black holes is a cosmic occurrence of enormous power and importance. These mergers have the potential to produce gravitational waves that can be detected by sensitive equipment on Earth and that have a significant influence on the universe's structure. Even though there are many unanswered questions regarding black hole behavior, research into their collision is an essential field that may provide answers to some of the most fundamental questions about the nature of the universe. I hope you liked this video. Please like and subscribe if you are new here. Also, press the bell icon if you want to see more interesting videos of our space.